So we've learned how to solve a system with two equations and two variables. Can we use those same methods to solve a system involving three equations and three variables? The answer is yes. We can use two of the methods, but not one of them. And the two methods that we can use are elimination and substitution. And I'm going to teach you how to use these two methods to solve a system, a linear system with three equations and three variables. Now, the other method was to use graphing, but the problem is what we're going to be graphing is three-dimensional. And since we only really know how to graph in the XY plane using two dimensions, we're not going to be able to graph these systems. So we're not going to use this to solve these systems. So we're going to use elimination and substitution. Now the thing is, when we have three equations, so let me write it like this. We're going to have equation 1, equation 2, and equation 3. The process is similar, but we're going to have to do twice the amount of work. So what we're going to do, just to give you an idea, and you're going to see this in our two examples, we're going to take two equations. You pick any two you like. So let's say we take the first two, and we're going to get rid of a variable. So if we had an x, y, and z, maybe you want to get rid of x. And how you're going to do that is you're going to use substitution or elimination. So maybe I can put that here. I'm going to put S for substitution or E for elimination. That's how you're going to get rid of one of the variables. And you're going to see that process in just a minute. But then when you do that, you get a new equation. So I'm going to call this a new equation. And this new equation will only have two variables. I'm going to call it new equation 1. And then what you're going to do is you're going to pick one of these, either equation 1 or equation 2, and use equation 3 to get rid of a variable. But you want to get rid of the same variable. And you're going to use substitution or elimination for that. And then what's going to happen is you're going to get, using these two equations, you're going to get a new equation. We're going to call it new equation 2. And that's in two variables. And then from there, you're going to consider this as a new system. So you're thinking of two equations, and then you're going to use substitution or elimination to solve for one of those variables. So for example, if this equation 1, equation 2, and equation 3 all had the variables x, y, and z, let's say you got rid of the variable z. So your new equation would be an x and y. And this new equation 2 would also be an x and y. And then you can use what we've learned before, because now you just have two equations, an x and y, and you're using substitution and elimination. And then you can find your point. You're going to find, let's say, find one variable, and then substitute that variable in to find the other variables. So again, here you have two equations involving x and y. Let's say you use substitution and elimination to find x. So then you know what x is. Then once you have x, you can come back here and find y. And then you'll have x and y. And when you have that, you can come back to any one of these equations and find x, y, and z. So we're going to have to use substitution and elimination, it looks like 3 times. So it's going to be more complicated. I'm going to show you how to do the first problem. Let's work it out together, and then let's see if you can do the second problem. Okay, so write down this first problem, and you want plenty of space. I would even say have a whole page of space for this one problem. So on one sheet of paper, write this problem down. You have x plus y plus z is -3, 2x minus 3y plus 6z is -21, and -3x plus 5y, I don't have a z here. You could put plus 0z if you want to, is equal to -14. And right here I have what I think is the solution. The solution is x is equal to 3, y is equal to -1, and z is equal to -5. When we have a point in three-dimensional space, we usually put x first, then y, then z. All right. So I'm going to follow this process I showed you just a minute ago. Now, if it doesn't make too much sense right now, that's okay. It will make sense in just a minute. So the first thing I'm going to do is I'm going to pick two equations. I'm going to pick the first and the second one, and then the second one and the third one. And let's get rid of one of the variables. And the variable we want to get rid of, we want to choose something that's easy to get rid of, if we can, if there's a possibility of getting rid of something. So here I have the first two and the second two. Before I do that though, I do want to mention that on your homework, you might see something that asks you, is this point a solution to this system? And all you have to do, which is very similar to what we've done before, is just plug in the x, y, and z into each equation and make sure you get a true statement. So if I said 3, -1, -5 is a solution, then if you plug these numbers into x, y, and z, you should get -3, -21, and -14. If you get a number that like this is -3, this is -21, and this is like 8, then it's not a solution. It has to satisfy each equation. Okay. Notice that in the third equation, there's no z. So because there's no z here, I think it would be a good idea to get rid of z, because the third one doesn't even have a z. So that's what we're going to do. We're going to get rid of the variable z. Okay, so to do that, I'm going to take these first two equations and I'm going to choose either substitution or elimination. It doesn't matter which one you choose. I'll do it both ways. So I'm going to get rid of z. The first way I'm going to show you is using substitution. To get rid of z, we solve one of the equations for z. The one that's easiest to solve for z is the top one, because if you solve this one for z, you have to divide by 6. So we have this x plus y plus z is -3. And then we had 2x minus 3y plus 6z is -21. So solving this one for z, we get z is -3 minus x minus y. I just moved these pieces over, and then I'm going to plug that into the second equation. So the first two equations, I'm going to plug the z in. So I get 2x minus 3y plus 6, -3 minus x minus y is equal to -21. Okay, so now let's distribute. We get 2x minus 3y. This is a -18 minus 6x minus 6y is equal to -21. And combine like terms. We have a 2x and a -6x. That makes -4x. We have a -3y and a -6y. That makes -9y. And this -18. Move that 18 to the other side. And we get -4x minus 9y. So here is an equation in two variables. So let's go back up to that little outline we had before. Right here. So I took equation 1 and equation 2. I got rid of z to make a new equation that is in two variables, and those two variables are x and y. Now, if equation 3 also had a z, I would take equation 3 and one of the other equations and get rid of that variable z as well. Now notice that for our particular problem, there's no z. There's 0 z's here. So this is actually an equation in just x and y. So we actually don't need to combine it with another equation. We just take equation 3 and put that here. That's going to be our, what we're calling our second new equation, and that one's in two variables. So let's write that equation, which is negative 3x plus 5y is negative 14. Let me just pause for a second. Okay, what I did was I erased all of that work. This was what we found z to be by solving here for z. Remember that we plugged it in here, and then we got this equation, negative 4x minus 9y is negative 3. So we're going to take that equation along with this one. Let's write that one down. Negative 3x plus 5y is equal to negative 14. So these are our two equations. And now we're just going to use regular, hold on just a second. We're going to use just regular substitution or elimination. Just like we've been doing before, pretending like this is our system. So you can choose substitution or elimination. I'm going to use elimination just so that we have more examples involving elimination. I think what I'm going to do, let's get rid of the x variable. So to do that, notice that I have a negative 4 and a negative 3. Let's multiply the top one by 3, and let's multiply the bottom one by negative 4. If we do that, notice that our system now becomes negative 12x, negative 27y is equal to negative 9, multiplying every single thing by 3. And then here I'm going to get a positive 12x and negative 20y. And this looks like a negative 56, a positive 56. Yeah. And notice why I chose one of them to be negative and one of them to be positive. I need these to have opposite signs so that when I add them together, they go away. So if you add these together, you get negative 47y is equal to, and then 56 minus 9. Let me pull out a calculator real quick. Give me just a second here. So 56 minus 9 is 47. So if we solve for y, we get y is equal to negative 1. Okay, let's go back to our little chart way up here. Okay, so let's review what we've done. We've taken equation 1 and 2. We got rid of z, and we had an equation just x and y. And then we had equation 3 that already was just an x and y, so we put it here. And then we used these two equations. We used elimination, and we found the variable y. So here, we found the variable y. And now what we can do is we take that y variable, what we found, and choose either one of these equations to solve for x. So plug that variable, that value in, solve for x, and then when we do that, we'll have x and y, and we can choose any one of these to find z, except for the third one, because in our particular example, that didn't have z. Okay, let's go back. So here is z. So let me do a little bit of erasing. Okay, so what I'm going to erase this piece here and go back to this system that we had right here. I'm going to erase this 3 and this negative 4. This was the original system. And then I'm going to choose either one of these equations. Let's go with, I'm just going to go with the first one. It doesn't matter which one you choose. So we have negative 4x minus 9y is equal to negative 3. And then I'm going to plug in negative 1. So we get negative 4x minus 9 times negative 1 is negative 3. Move the 9 to the other side. So we get negative 4x is equal to negative 12. So x is equal to 3. So now we found x, we found y, and the last thing we want to find is z. And because we use the substitution method, oops, sorry about that. Since we use the substitution method, we can plug it into this z that we found earlier. So let me just erase some of this. So here's our y. And here's our x. So then just plug it into this equation. We get z is equal to -3 minus x minus y. So z is equal to -3 minus 3 minus 1. Let's make sure I didn't do anything. Plus 1, because we have a minus y, so that becomes plus 1. So we get -6 plus 1, which is -5, which is what I have written here. We have 3, -1, -5. So that is the correct answer. Now, in case you didn't circle this, or you have a hard time finding where z is equal to something, or if you didn't even use substitution, let's say you used elimination, then just plug it into one of these equations. So one of these two to solve for z. Now, if you wanted to use elimination, let me just review that really quick to show you another option, because in the very beginning of this problem, I used substitution. What I did was I solved for z and then I plugged it in here, but you don't have to do that. You could use elimination. So what you could do is say x plus y plus z is -3, and then we have 2x minus 3y plus 6z is -21, and you try to figure out which variable you want to get rid of. We wanted to get rid of the z variable. So here's our system. To get rid of z, notice that this one has 6z, so we need to multiply this equation by a -6. And if you do that, you get -6x minus 6y minus 6z is equal to 18. And then the bottom equation is 2x minus 3y plus 6z is -21. And then you add these two together, you get -4x minus 9y is equal to -3. And I believe this was the equation we had before, where they were all positive. And yeah, so this would be the first equation. And then again, we use this equation and we would get the same answer. All right, let's do one more problem. So here's problem number 2. I have 3x plus 3y plus 2z is 4, x minus 3y plus z is 10, 5x minus 2y minus 3z is 8. And the solution to this problem is right here, 2, -2, 2. So let's see if we can actually get to this solution. So what I'm going to do is I am going to choose two equations, which I'm going to choose these first two, and then I'm going to also choose these two, and I'm going to get rid of one of the variables. It doesn't matter which variable you get rid of, x, y, or z. I would go with something that's really easy to get rid of. What I notice just by looking at these problems, if I add these two together, I'll get rid of the y. So maybe we should get rid of the y. That would be probably the quickest thing to get rid of, but you don't have to. You can get rid of maybe the x. You can multiply this equation by -3 and get rid of it. Or you can get rid of the z. You could solve for z and then plug it into here, whatever you want to do. What I'm going to do is I'm going to get rid of y from the first two equations and then this two. So maybe pause the video, see if you can get rid of y, and then check and see if you get the same thing I get. Okay, so let's go with this. We have the first two equations are 3x plus 3y plus 2z is equal to 4, and x minus 3y plus z is equal to 10. What I'm going to do is I'm just going to add these two together. So I get 4x, the y's go away, plus 3z is equal to 14. Okay, I'm going to erase this, and I'm going to put that this new equation that we found is right here. 4x plus 3z is 14. So 4x plus 3z is 14. So we got rid of, let's put that here just so we can follow our outline. We got rid of y using elimination. I'm just going to use e. I don't want to write the whole word out. And so this is our first new equation. So we need to write another new equation. So I'm going to do the same thing. I'm going to get rid of y. Now here, this is going to be a little more complicated because we can't just add these two together and get rid of y. So we can either multiply the top and the bottom by some scalar and then add them together to get rid of y, or you can use substitution. It doesn't matter what you use. So let me erase this. And then we're going to put these two equations down here. Let me just copy them like this. So here's the two equations. What I'm going to do is I can multiply the top equation by a -2 and the bottom equation by 3. That way I get +6 and a -6. And then when I add them, that y goes away. So let's do that. I'm going to put it over here. So -2x. Remember, this -2 has to go to everything. It's really easy to make a mistake. So be careful here. So -20. Just double checking here. And then the other one is 15x, zoom out a little bit, -6y minus 9z is equal to 24. So those are the two new equations. Just double check. Okay, add them together. We'll get 13x. The y's go away, minus 11z is equal to +4. So that is the second new equation, 13x minus 11z is equal to 4. Okay, if you wanted to use substitution, you can. You could maybe, I would probably solve for this y, and then you would get something involving this 5x and this 3z and this 8. You would divide it by 2, and then you would plug it into this y here. Okay, and you should get something similar to this equation. Okay, now that we have our two equations, let's get rid of all of this. And now we need to get rid of another variable. So you choose the variable you want to get rid of. It doesn't matter which one you choose. I think it was going to take the same amount of work for either variable. So we need to get rid of another variable. So we got rid of, let's choose a variable here. I think I'm going to get rid of z. You can choose x and see if you get the same answer in the end as I do if you want. So to get rid of z, what I'm going to do, I'll use elimination as well, because if I use substitution, I'm going to have to deal with fractions. I don't want to do that. So I'm going to rewrite these down here. So maybe I'm going to copy these, put it down here, and then I'm going to have to figure out a number to multiply both equations by, could be different numbers, to get rid of z. Remember what my goal is. So to get rid of z, why don't I multiply the top one by 11? That will give me 33, and the bottom by 3, that'll give me -33. And then when I add them, they go away. So if I do that, I'm left with 44x plus 33z is, okay, I think I might need a calculator for that one, just so I don't make a mistake, 154. And then we get 39x minus 33z is equal to 12. All right, so now we can add these two together. Let's see, we get, this is 166. This goes away. And then here we have 44 plus 39, that's 83. So 83x. And if we take 166 and divide it by 83, we get 2. So we get that x is equal to 2. So we found our first variable. Now that we have this variable, we choose either one of these. So let me put right here what we did. We found that x was equal to 2. Choose either one, plug in this x value, and then we'll get z. Okay. So So let me erase all of that. I like to see my problem when I'm working it out. So we have 4x plus 3z is equal to 14. So I'm going to plug in this 2 for x. I get 8 plus 3z is 14. Okay, and now subtract 14, we get 3z is equal to, that's 6, I believe. So z is equal to 2. So now we found x and z. So we're going to use both of these, plug them into any one of these. Now you probably want to go with the least complicated equation. I'm going to choose the second one because there's no scalar in front of this x. And then we should be able to find x using that. Okay, so I'm going to write the equation down here. X minus 3y plus z is equal to 10. We have x is 2 minus 3y plus z is 2 is equal to 10. So we get negative 3y plus 4 is equal to 10. So 6 is equal to negative 3y. And then y is equal to negative 2. So we did get that ordered pair, which was 2, negative 2, 2. The x being 2, the y being negative 2, and the z being 2 from this original point. What I want to do next is I just want to show you how to double check. Now you can see we did a lot of work, and sometimes you'll get the answer wrong. Like if you plug it into your homework, they'll say, oh, this is the wrong answer. So one way to double check this, get 2, negative 2, 2, is just to plug these in, right? So if we plug them in, 2, negative 2, 2, you'll get, for the first one, 6 minus 6, and then plus 4. We get 4. Then check this one, 2 times a negative 2 plus 2. So this is 2. This becomes plus 6. So that's 8 plus 2 is 10. That's right. And then if you plug it in here, you get 10 minus 4. Well, actually, y was a negative 2, right? So the plus 4, and then minus 6. So that's 14 minus 6, which is 8. So that works. If it didn't work out, I would go back to the very beginning and see if you made a mistake there. Sometimes it can be hard to double check and see if you made a mistake. So if that happens, if you can't figure out where you've made your mistake, I'm going to give you a suggestion. And that is in the very beginning to redo the problem. And you know how we chose these first two and then these two? What you can do instead is you could choose these two and then these two. So this problem, so this equation with this one and then these two. Or what you could do is you could go with these two and then these two. To try to get around that mistake. Because if you can't see it, maybe if you try to do the problem differently, then you can find the mistake, if that makes sense. You could also, like, you know how we used elimination for all of this? You could use substitution, like just trying it a different way, because sometimes if you just look at your work, you don't see the mistake. So that's my suggestion for these problems. They can get hard, they can be complicated, and they can be frustrating, but you just have to keep trying.